Hi, I'm Cullen. Welcome back to Module 8 of Networking Fundamentals. We're going to talk about networking services. Let's go ahead and jump right into the agenda here. We're going to cover two different objectives today. We've got understand networking services, and we'll detail common network services that are available. And then 3.4, understanding name resolution. This is one of my favorite topics to discuss. And we'll just go over the name resolution techniques that are available, okay? All right. Without further ado, common networking services. So DHCP, or Dynamic Host Configuration Protocol, is the protocol that enables our computers to obtain IP addresses automatically. And so the IP information obtained is probably going to include your IP addressing information, your IP address itself, a subnet mask, a gateway address for your default gateway device, the router, and then your DNS server address. We'll talk about what the domain name system is in detail here in a little bit. And then there are some other advanced features and options as well that can be included with DHCP. The server definitely provides a really reliable IP address configuration, and also too, it makes it really, really easy for network administrators, because frankly, I certainly wouldn't want to assign an IP address every time that a device connected to the network, not with however many devices there are now in existence on any given network too. So, all right, so let's talk about the DHCP server and how that process works. It starts leasing an IP address to client computers after the following steps are performed. And so you see the steps there. Clearly, you have to install the DHCP service on a server before it can be used. You configure an IP scope, activate that scope, authorize the server, and then configure any other advanced options. And of course, those are optional, but if you're a really good network administrator, you're probably going to be configuring those advanced IP options. I honestly probably am not there yet myself, but someday, right? All right. Let's talk about DORA. So DHCP sessions, when they begin, they use a four-step process known as DORA. The first step in this process is discovery, and that's where the client sends a broadcast to the network just simply to find a DHCP server. So note here, it says, that computer says, hey, are there any DHCP servers here? That is the discovery process. And whoops, doesn't want to let me have my marker. That's the discovery process, right? Next, that server is going to respond, and it sends a unicast message offering an IP address to the client. Then, of course, we have, so I'm going to check these off as we walk through them. We have a request where the computer says, hey, I would really, really like that IP address. Please send it over to me. And then the DHCP server sends a final unicast message to the client that includes the IP information, right? So there's ACK is short for acknowledgement. That's where it is. Quick little point too, and I know that we discussed this in a previous slide, DHCP, just like most protocol, well, just like all protocols, apologies there, all protocols is going to use ports, a port, specifically ports 67 and 68, okay? All right, so we talked about APIPA a little bit earlier as well. APIPA is another service, a networking service that makes things really nice for us. It assigns that unique IP address that starts with 169. When no DHCP server is available. And so APIPA, though, can cause us some troubles too, because if you have an APIPA address, a 169 address, then it makes it difficult for us to obtain an IP address properly from a DHCP server sometime, right? So when a client attempts to obtain an IP address, the DHCP server might be too busy, or some other issues might come up. And so it will prevent a computer from accessing the internet if you have one of those addresses. But the good news is that you can use it to access and communicate with other devices on your local area network. Next up, we'll just touch on this real briefly, remote desktop services. These are super useful so that you can access computers remotely across a network. And so we use remote desktop services to enable a virtual desktop infrastructure. And so this is just session based, so we're able to access it. We can log into a desktop remotely and then start a session and then end a session, right? We can use its applications. We can basically work from anywhere if we use something called a thin client, right? It's a type of computer that doesn't have a lot of resources and intense hardware, right? It's thin. But we're able to use those computers because we can just connect to servers that run remote desktop services, which enable remote access. So, all right. Next, and this is one of my favorite topics, name resolution techniques. I love talking about DNS. I think that this is super fascinating. It's a worldwide service. Domain name system is just a worldwide service that resolves host names to IP addresses. So if we have www.bing.com, we can go ahead and resolve that to an IP address, and vice versa, right? It does translation. DNS architecture is just hierarchical and distributed, and it has an associated set of protocols that define a mechanism for querying and updating a database. It has a really extensive database that aligns names with IP addresses, and that's very similar to like a telephone book that aligns telephone numbers with names. And of course, for some of you, you may not even know what a telephone book is because those are starting to go the way of the dinosaurs. But let's look back at our slide here real fast. DNS is part of TCP/IP, and then the servers are going to use inbound port 53 to accept name resolution techniques. Okay. I want to touch back real fast on hierarchical and distributed. Okay, what this means is that there are a bunch of different servers, and some have greater importance or more so importance than others, right? So they're hierarchical, so others have greater powers, I guess you could say, than others. They're higher on the food chain or lower on the food chain. Lots of different ways you could talk about it. But when you type in an address like bing.com, there's actually an invisible period on the end of com, and that actually points you to the root server, right? And then below the root server, we have a .com server. And next to the .com server could be like a .net server. And all of these servers know the location of maybe like the server or the DNS server that's used for Bing. Right? So pretty cool stuff. We'll detail that here in just a second. All right, so how does DNS work, right? So what happens is you have a client. So I forgot my desktop icon, so I'm going to draw my funky little laptop here. And it's going to try to send its request to a name server. It's going to do that through a device called a resolver. Our clients through the resolvers are able to access forgive me, I just messed up in my speech. Clients access resolvers, which are libraries, and then those libraries perform DNS queries. They do so by making recursive queries to name servers, right? And this name server might be located at your internet service provider, somewhere locally close to you. And so that resolver expects to see a response with either the destination IP address, like the IP address for Bing, or an error message saying, I cannot find this this IP address for this specific name, okay? Now, what happens when the resolver goes to work, it expects that response, and it tries to get it from the name server. The name server might go do some work in the background, and it actually embarks on making some iterative queries. And so what happens first is if the name server doesn't have the address, the IP address, in its cache file, or really, which is like the phone book reference that I made earlier, it's like a phone book, then what it's going to do is it's going to go ahead and send an iterative query to the root name server. The root name server may have the address. If it doesn't, it's going to tell it where to go, and maybe it tells it to go to the com server. So we went here, The name server says, no, I don't have it, but I can tell you where to find the comm server. Well, then the comm server sends back perhaps the IP address. And then we just skip straight to step 8. The resolver then sends us back the IP address, and all of a sudden, here we are. We have Bing on our screens. Okay. Let's talk about WINS. WINS is another name service that's available to us. It resolves the NetBIOS names, right? Those logical names that our computers have to IP addresses. WINS is required for any environment which uses NetBIOS or where any of our devices have NetBIOS names. And it's just Microsoft's version of the NetBIOS name service, right? It's combined with the name server. So WINS and DNS, they're both name resolution services for TCP/IP. Pretty simple to understand. But still a lot of complexity involved. So do take your time and take care in understanding and learning this information. All right. So that's it for this module. Just a quick recap. 3.5, understand networking services. We talked about common networking services, and we also talked about different name resolution techniques with DNS and WINS. Hope you guys enjoyed it. I know it was a pretty quick one. Thanks so much. I'll see you next mod.